All right. Now that you've had the opportunity to read over the class example, you should have downloaded it or at least looked at it and read it over, and the explanation of the t-test, I'm going to walk you through computing the t-test, the independent samples t-test in Excel. So here I have my Excel worksheet up. I've titled it Class Activity Number 4. I titled mine recording because it's the one I'm recording, but when you do yours, you title it Class Activity Number 4. You're going to enter your scores that is in your handout, which is for the measures about bullying awareness. We're going to pretend like we administered a standardized scale about bullying awareness to the boys and the girls in the first grade, and these are their scores. So you create one column for boys, one column for girls, enter their scores down just like they are on the paper. Once you get that there, remember what we want to know is we also want to do our descriptive statistics for each so we know what the mean is for each one, the range, and all the other information. So I'm going to hop on over here to my data analysis, which is up here in the corner. Remember that. Click that up. Get that data analysis tool up, and I'm going to go back to my descriptive statistics, something that we've used quite often. Let's see. I want to see what the boys are first. So I'm going to capture all their scores. Come down here, and I'm going to tell it where I want it to go. And I'm just going to put the boys' scores right here. And I want my summary statistics. So there I go. So then I have the boys' scores for bullying awareness. Come back here, reorganize these into my 2 decimals. So I know the boys have a mean of 5.3, standard deviation of 3.2, a minimum and maximum of 1 to 15. There were a total of 30 participants. So now let's see what we get for the girls. Let's go back to our data analysis, our descriptive statistics. Let's change our input criteria. Right here, let's grab all these girls' scores. Go back over here, let's change our output range. Let's put the girls right next to the boys. Got our summary statistics clicked right there, so we're going to hit OK. And so this is going to be the girls' scores. I'm going to clean this up just a little bit by doing my default range there. And so the girls' scores have a mean of 5.53, which is a little bit higher. Standard deviation of 2.6. They've got a tighter range there, not quite the variance. And then there's a total of 30, so I captured them all in there. So looking at these two, we actually then think, well, the girls scored has a slightly higher mean on this, so maybe they have a higher level of bullying awareness. But what we really want to know is this by chance, or is there some meaning behind this? Do for some reason the girls in this class have a higher level of bullying awareness? So we have to perform a significance test to determine that. And everything that we talked about before has to do with our significance, our statistical significance of, is this happening by chance, or is there a real meaning behind the difference that's here? So for this one, we're going to compute the independent samples t-test. What that means is it's called a student's t-test or an independent samples t-test. I have 2 independent samples. I have the boys and I have the girls, and I measured them on the same measure. So I'm comparing their mean scores on this one measure to see if this difference is by chance or if there's some meaning behind it. So what I'm going to do is I'm going to go up here and I'm going to pull up my data analysis again. And when I scroll down here towards the bottom, I have my t-test here at the bottom. You see a t-test for paired 2 sample means. We're going to use that in a minute, but that's actually for when we're testing one group on two different tests. So that's like a pre-test, post-test. So that's a different one. This one, we have the option of choosing the t-test, the two sample, assuming equal variances, or the t-test, the two sample, assuming unequal variances. So two samples, again, means I have two independent samples. Here I have boys and I have girls, and they took the same test. I'm going to choose the t-test with two sample, assuming equal variances. And the rule of thumb for this is I choose this one because I have a sample size that's below 40. Again, there's some statistical assumptions and some theoretical basis for this, and we're not going to get into all of that right now unless you just really want to. I can talk about the theory behind this all day long. But just know that if you have a sample that's below 40, you select the t-test two sample assuming equal variances. If you have a sample that's more than 40, then you take the t-test two sample assuming unequal variances. That's the only thing you need to recognize at this point on which test to choose. So I'm choosing the two sample assuming equal variances, and I'm going to hit OK. All right. Now when this window comes up right here, I have variable range 1 and variable range 2. So remember, I have two groups here. So my variable range 1 is going to be the boys. I'm going to capture that, and I included the label in that. Because right here I'm going to click labels, and so that it'll put my labels out here. My variable range 2 is going to be the girls, and I'm going to capture those, and I included my label in that. So it'll put my labels out here. My output range, I'm going to come over here. And I'm going to capture just this right here next to it. And you can just put it in one. You just need to make sure you have enough room because it's going to be a fairly good size table here, kind of like your descriptive statistics table. So I'll just capture it right here. Go ahead and put it like that. And then I'm going to click OK. So right here, it tells me I just ran the test, the t-test, the two sample assuming equal variances. Group 1 is boys, group 2 is girls. Let me clean this up a little bit, get this down to the 2. Okay, so it gave me my mean, and we got our mean in our descriptive statistics over here, so we're good there. It gave me my t-statistics, which I need to know. It gave me my degrees of freedom, which I need to know. And then it tells me I have a one-tail critical p-value and I have a two-tail p-value. Remember when I told you for hypothesis testing, we have to understand if it's a one-tail or a two-tail? For this particular class exercise, if you go back to your handout, we chose a very specific hypothesis. Our hypothesis is that the girls in this first grade class will score higher on bullying awareness than the boys. So we named a direction. We think that they're going to score higher. So that means it's one tail. We're saying there's a specific way the difference is going to go. So the one that we have to look at right here is the p-value for the one tail, because that's what our hypothesis said. We established that ahead of time, and then we know what to look at right here. So our p-value is a 0.44. Our alpha value that we set was 0.05. So we said that anything that was 0.05 or less, we would accept as being significant. Anything that is over 0.05, we're saying it is not significant. 0.44 is a lot larger than 0.05. So what we're saying here is that this difference, this mean difference right here, happens strictly by chance. The girls do not have a higher level of awareness than the boys based on what we ran right here. So those are the things that we look at in this output. And you'll see you get basically the same output in terms of the mean and everything when you do this, but you need your descriptive statistics because, again, when you start writing your results, then you're actually going to include your minimum and your maximum scores. You need your standard deviation to go along with your mean. So you have to run both of these to be able to get all the information you need to report. Let me go back over here and highlight that for you. So I'm going to go back over here and I'm going to capture on my other one the information so I just don't have to rewrite it and bring it back over here so you'll be able to see. Again, these are the things in this conclusion. This is, as a researcher, this is what you would be looking at. Now, this is not what you report, but this is what you'd be looking at. So what we're saying is the observed difference between the sample means, which is what t-test evaluates, is not convincing enough to say that the higher average score for awareness of bullying behaviors for girls differs significantly than that for the bullying awareness of boys. We're saying it just happened by chance. So this is how we report those findings. An independent samples t-test was calculated comparing the mean score of first grade girls on a bullying awareness scale to the mean score of boys. We just stated what we did. No significant difference was found. In reporting our findings, we have to include the T statistic. Right there, you'll see the T with the parentheses of 58. So right here, it says my T, and then my degrees of freedom is the 58. So that's T degrees of freedom equals a negative 0.14, which is my T-stat right here. If I take all of this and make this to the 2 decimals, there's my T-stat, negative 0.14, at an alpha level of 0.05, because that's what we set. So in reporting as T-statistic, these are the numbers you have to pull out of your findings. You indicate it's the T with the small t italicized. In parentheses, you put the degrees of freedom, which is reported right here, equals, and then you report the T-stat. In this case, it's the negative 0.14, comma, P is greater than 0.05 because our P-value was 0.45, so it's over the 0.05. The mean score for bullying awareness scale for girls, there's our mean, which is 5.53. Our standard deviation is 3.42, was not significantly different from the mean score on the bullying awareness for boys. Mean is 5.43. Standard deviation is 2.06. That is all you need to do in Excel to run an independent samples t-test to compare the mean scores of 2 samples. So what this means is when you have an interval ratio level variable, which is our test that we administered, and you have 2 groups, you can calculate a t-test to determine if the difference between the 2 groups is significant or not. Not complicated at all. Just to review, you go back, you go to your data analysis, you pull up your data analysis, you're going to scroll down to the bottom, you're going to find the t-test at the bottom. If you're comparing the 2 groups on one measure, you're going to select either 2 sample assuming equal variances or 2 sample assuming unequal variances. You choose one of these based on your sample size. If your sample size is below 40, you choose 2 sample assuming equal variances. If it's above 40, you choose 2 sample assuming unequal variances. And then you compute your statistics. Then you go back and you read what your statistics are. Remember, you have to set your hypothesis ahead of time, and you have to set your alpha value ahead of time. We always set our alpha value at 0.05 in social sciences. It's just the given, it's just what we do. So we set it at 0.05, and then you name your hypothesis. You determine, is your hypothesis one-tailed or two-tailed? In our case, it was one-tailed because our hypothesis was that the girls were going to score higher. So that's where we select that. And it is way above our 0.05. So our findings were just by chance. There's nothing here to say that the mean score of the girls was significantly different than the mean score of the boys. Just pure accident that they scored higher on bullying awareness. So that covers the independent samples t-test in Excel. Follow your handout. Follow this instructions right here. Compute your class activity number 4, exactly like what I've done here, and include it in your next submission when you submit your homework number 4.